Hello all, myself Professor Ojimuri, working in All India Sri Shivaji Memorial Society's Institute of Information Technology, Pune, in the Department of Information Sciences. Today, we are going to see how the refrigerator works. In this session, we will complete the definitions of the refrigerator, then concept of refrigerator, vapor compression refrigeration cycle, working of the refrigerator, and the applications of refrigeration systems. So, if we start with the refrigerator, so we should know what is the refrigeration. Refrigeration is the process of production of cold confinement relative to surrounding. That means we have to keep the temperature of confined space below atmospheric temperature. That is, the process of producing heat and maintaining the temperature of a body below general temperature of the surrounding. So how this effect is produced, the cooling effect. So to produce the cooling effect, so we are using one substance that is called refrigerant. Refrigerant is nothing but working substance used to produce cooling effect in the refrigeration cycle. There are various types of refrigerants used in the refrigeration cycle like chlorofluorocarbons, that is CFCs, including R12, hydrochlorofluorocarbons, including R22, hydrofluorocarbons, HFCs, including R410A and R134. Before going to ahead, we should know what is 1 ton of refrigeration, that is unit of refrigeration. 1 ton of refrigeration, that is 1 TR, was defined at the rate of heat transfer required to make 1 ton of ice per day from water at 0 degrees Celsius. So 1 TR is equivalent to refrigeration capacity of 3516.85 watt. That means cooling effect produced by melting 1 ton of ice from and at 0 degrees Celsius within 24 hours is the 1 ton of refrigeration. In general, 1 ton of refrigeration is equivalent to 3.5 kilojoule or of heat removal per second. The rate of heat absorbed from body to be cooled is the refrigeration effect that we already know. The refrigeration effect, that means where amount of heat we are removing per unit time from the space to be cooled by the refrigeration process, it is explained in terms of kilojoule per second or in kilowatt. The main unit of refrigeration is ton of refrigeration. It is the rate at which the heat is removed from 1 ton of refrigeration of 1 ton of water at 0 degrees Celsius, ice at 0 degrees Celsius in 24 hours. So we should know how we can measure the performance of refrigerator. So we are measuring the performance of refrigerator in terms of coefficient of performance like efficiency. So we can define the coefficient of performance, that is the COP. It is the ratio of desired effect to the work input, or we can say refrigeration effect to the work input. COP of the refrigerator will be always greater than unity of 1. So it means it is the measure of effectiveness of refrigeration system. It is the ratio of refrigeration effect Q to the heat input or work input required to produce the effect, that is Q divided by Q divided by W, or you can say QL divided by network input. So now we have completed the basic terms of the refrigerator. Now we should know on which refrigeration cycle and on which component a refrigerator works. So basic components of the refrigerators are compressor, condenser, expansion valve and evaporator. So if you see this diagram, in this diagram, so you will find the household refrigerator. The condenser coils are placed outside the refrigerator or the fridge. Inside the fridge, we are locating the evaporator coils. Then bottom of the same there is compressor, expansion valve. These are the four major components of the refrigerator. Now, before proceeding, we should know a VCR cycle, that is vapor compression reduction cycle. So, as I mentioned, there are four components: compressor, evaporator, expansion valve, and the condenser. So, where it is located? So, compressor is always placed bottom side of the refrigerator behind. So, compressor compress low low refrigerant gas to the high refrigerant. That means it converts low pressure refrigerant into the high vapor refrigerant. Now, then it will be high vapor refrigerants coming in contact with the condenser. Condenser coils are placed backside of the refrigerator or the fridge. So due to the fluid, due to the coming in contact with the refrigerant coming in contact with the surrounding air, there is a change in the high pressure refrigerant into the high pressure vapor refrigerant, and that high vapor refrigerant will reject the heat to the surrounding, and that high vapor refrigerant coming into the expansion valve. Now in the expansion valve release, it works according to the load condition. It's according to the load conditions or the load variation on the refrigerator or the components inside the refrigerator. So expansion valve release as per the load and supply the refrigerant to the evaporator. Evaporator is the main component, or we can say the brain of the refrigerant, which controls the temperature inside the occupied space of the refrigerator, or occupant space, or maintain the cooling effect. Due to the conversion of low pressure refrigerant, high refrigerant into low refrigerant, so it comes in contact with the uh, evaporator coil, and that evaporator coil converts liquid refrigerant, vapor refrigerant into the liquid refrigerant. So, which are the components of the, in detail we'll see the components of the refrigerator. The compressor is the heart of the refrigerator. It circulates refrigerants throughout the system, add the pressure to the warm part of the circuit and make the refrigerant hot. It is similar to when you are pumping power into bicycle tube. You can see the sense the heat increase in the pump while you compress the air. Next part, condenser. Condenser is backside of the refrigerator and is to inside the likely inside the refrigerant is to be cooled down and condensed meanwhile enters from gas back into the liquid. Evaporator is located inside the refrigerator, already we have covered. So it is the part makes items refrigerator cold. and the refrigerant turns liquid into the gas throughout the evaporation. And that low pressure vapor refrigerant is going to the compressor again. So now how it is working. So before going, we should know what is a capillary. Capillary tube is the another one part of the refrigerator. So capillary tube is a thin piece of tube that serves as the expansion device. The liquid refrigerant is routed through the capillary tube and sprayed into the low pressure environment of the evaporator. Next to that, the thermostat valve is there. That thermostat valve controls the cooling process by monitoring the temperature and then switching the compressor on and off as per the load variation. When the sensor senses that it cold is and inside the refrigerator, it turns off the compressor, and if the sense too much heat, it switches the compressor on and begins cooling again. So picture shows the thermostatic valve as well as the expansion valve. On the left hand side, we have shown how the refrigerator works. So if you see the cursor, the first will go with the compressor. So compressor converts low pressure vapor refrigerant into the high vapor refrigerant. So while coming that low pressure vapor refrigerant, low pressure low temperature vapor into the, what I can say, into the mm, condenser. So when it is coming into the condenser, so that condenser conversion of high vapor low to high vapor high temperature refrigerant into the condenser. Condenser refrigerant is in contact with the surrounding air, so it will convert into the high pressure high temperature liquid vapor mixture, and that we are collecting into the collector and the expansion valve, and that expansion valve is working as per the load variation on the evaporator and supply the refrigerant to the evaporator as per the load variation. What happens when the high pressure high temperature liquid refrigerant come in contact with the evaporator coil? It again convert from, due to the refrigerant into the low vapor low pressure liquid mixture, and converts the absorbs the heat rejected by which we are keeping inside the evaporated space, and that refrigerator will convert low pressure refrigerant into the uh, liquid refrigerant into the low pressure vapor refrigerant, and it is again transferred to the refrigerator. So it means cooling effect is produced inside the evaporator coils. So major applications nowadays, there are so many applications area, or it is a promising field due to the comfort zone of all the uh, peoples or the all the processing industries. So there are various areas where the refrigeration concept is used: food processing, preservation and distribution. Next, chemical and processing industries, special applications such as cold treatment of metals, medical industries, construction industries, comfort air conditionings, etc. So many areas where the refrigeration concept is used. Thank you.